Hello everyone, I am Suputra Pancha, Assistant Professor, Department of Computer Science and Engineering, BADLVP, Dr. PG Harkatti College of Engineering and Technology, Vijaypur. In the last class, I had discussed about double transposition cipher, and in this class, I will discuss the one more technique of cryptography, that is one-time pad. So again, I will review this module or module level outcomes, and in that these methods will come under the second module level outcome, that is module 1.2. So now in this we'll be discussing one-time pad. What is actually one-time pad? So it is also a concept to encrypt the data, which may be in the form of plain text at the sender side, and at the receiver side, receiver has to decrypt and get the original plain text. The idea behind this one-time pad is here, for the user, different types of letters will be given, and along with that, binary numbers will be assigned. So based on those binary numbers, we will be using the respective key. So each pair of, for each letter, we will be using one key value which is also in binary, and we will be performing XOR operation between each letter with key, and after that we will be getting cipher text. So this is what the concept in one-time pad. So here, for example, initially there are some letters here, say for example E, H, I, K, L, R, S and T, and along with that, for each letter binary numbers are also assigned. Say it starts with say for example 0 to something like 7, 0, 1, 2, 3, 4, 5, I mean 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, like that. So by using these letters, so now what we have to do at the sender side is how to perform encryption algorithm. It's very simple in this one-time pad, that is plain text is XORed with key. That means each letter in the plain text is XORed with the given key binary number to get the particular letter in cipher text. Now this is what the process here, that entire process. Assume that here in this example, plain text is say Hail Hitler, H-E-I-L H-I-T-L-E-R. For each letter, so we will be assigning binary numbers, and these binary numbers will be allocated based on the given value which is given at the top. Say for example for H, we have to find out the binary number for H. Here in this is, that is 001. That 001 is considered, and for E here is 000. 000 is considered. For I it is 010. 010 is taken. Similarly for the remaining letter L, H, for L it is 100, for H it is 011, for I it is 010, like that, and for R it is 101. Say for example, and one more thing, for each letter, as I said earlier, for each letter the respective key is used. I mean this key is given. This key is, that is nothing but symmetric key, is given both to sender as well as receiver. So here, based on the number of letters in the plain text, the number of keys will be given. So for H, I mean for 001, this particular key is used, that is 111. For E, 101. This is standard for this particular example. That will be used both for sender as well as receiver, and this key may be changed for another example. It's not fixed. So now here, very simple, we'll be performing the XOR operation between plain text and key. That is, so if you perform XOR operation between 1 with 1, which is 0, and wherever there is a 10, that will be termed as 11, right? So for the first answer it is 110, second one 101. So now we'll be getting these binary numbers in the cipher text. Based on the binary numbers, again we will be converting those binary numbers into respective letters. So here once again we have to find out 110. So this 110 is assigned to which letter? Which is yes here. that S will be written here. 101 is assigned to which letter? 101, that is R. R is assigned. Similarly, 100 L, H. So like that, for each binary number we will be translating that binary number into letters. That is S, R, L, H, S, S, T, H, S, R. This is the ciphertext. So plain text is given, and from the plain text, the binary numbers for such plain text will be given. That is initially, along with that key is given, and that key should be known both to original sender as well as receiver. Based on that key, we will be performing XOR operation between plain text and key to get ciphertext. This is what the concept known as one-time pad. And exactly in the decryption process, so the procedure is exactly reverse once again. Now we'll go for that decryption process. So in that decryption process, what we have to consider initially is again the same letters, that is E, H, I, K, L, all those things. And after that, so we'll be considering the decryption, say we can say algorithm, that is ciphertext XORed with the same key, which is equal to plain text. So this is what the entire procedure here. So we will write ciphertext for S. What we have to write is 110. Again same thing for R, 101, like that. We will write the bundle number and the same key is used, and again performing the same XOR, we will get the original plain text, that is Hail Hitler. So this is what encryption and decryption process in one-time pad. So now one more important fact about one-time pad. So is it possible to cryptanalyze? Is it possible to hack one-time pad by the hackers? So this is our simple question. So that we will discuss it here. So we can see that what agents, what hackers can do. So agent here in the sense something else, hacker, a double agent. So it's a name, double agent, claims following key was used. Claims in the sense, so that agent will be assuming, say, this particular key was used for this particular operation, this particular encryption and decryption process. So he is assuming something, and what he decides, what that agent decides is, so he will be trying to calculate. He will be trying to retrieve the original plain text. So how exactly it is? So again, so he knows this ciphertext. I mean S, R, L, H, S. Based on the ciphertext, he tries to claim the key which was used earlier. Yes, he will assume, he will claim, and he will claim the key as 101, 111, something which is different. That's what we have used for our encryption and decryption example. So now he performs the same. He knows the algorithm. And he tries to get the key which was used. He claims the key was used is this, and he performs the same thing, that is ciphertext XOR key, and he'll get the binary numbers, and he after getting the binary numbers, try to convert it into letters, and what he gets is kill Hitler. I think kill Hitler in the sense it is a well-known English sentence, kill Hitler. So what he decides, yes, I got the original plain text only. What agent decides that he got original plain text only, but actually it is not the original plain text, but the original plain text is Hail Hitler. So again, for this only, that agent has to use the same letters, that is E, H, I, K, the same letters. So, or one more possibility, or claims the key is. So one more try. So what he can guess is, so you can see this, that is one more try. It starts with 110 something else, and what he got from that output is HELI, something else different. HELI, KESI, this is another plain text, but what agent decides is this is not the plain text, but the earlier one, what he has decided, this one what he assumes is the original plain text only. So totally right. The one-time pad summary, what I need to tell you is, what we can decide is it is provably secure. So why it is provably secure in the sense, every time sender and receiver will be using the different keys. The key will be not fixed. And one more thing, and sender and receiver will not use the keys in directly in binary form. So if they want, they can use the key in the form of messages. So that's what we can say, this one-time pad is probably secure. Ciphertext gives no useful information about plaintext. All plaintexts are equally likely, but only when we used correctly. Pad must be random. Pad here in the sense key. Key must be random. I mean what I said earlier, the key will be used different every time. Used only once, and one for one particular transmission key is used, that will be removed, and again the fresh key will be used for the next transmission, for the next encryption and decryption algorithm. Pad is known only to sender and receiver. Note that key is same size as message. I mean key will be used both by the sender as well as receiver with the same size. So why not distribute message instead of pad? That's what I said. Instead of key, the original sender as well as receiver can distribute the messages. So this is what a one-time pad. So in the next class, I'll be discussing some of the which are all applications in the earlier days used by this one-time pad summary. There are some examples. I'll discuss it in the next class. Thank you.